So welcome back guys. I'm back with another video on Flowcytometry, and it took me a lot of time to upload this new video for one very simple reason. I'm not a very tech savvy person, and it took me a lot of time to understand these green sheets and how to use them. But slowly and slowly I'm understanding these tech glitches, and maybe the subsequent videos won't take so much of time. Now let's start with today's lecture, which is about the plots and the gates, and how with the help of these plots and the gates you can identify the component of the sample that you want to analyze. Now that sample may be coming from the peripheral blood, or may be coming from the bone marrow, or from various type of body fluids that you have. Now let's start with the today's video. But before we start, we will just have a quick relook in what we have understood from our previous lecture. For that, what I have done is we will take up this cell, and when this cell gets stricken by this laser light, there is going to be some amount of deviation produced in this laser light path, and this deviation produced on a single dimension is called as forward scatter height, and the same thing on a two-dimensional plot will be seen as a shadow, and the area of this shadow is called forward scatter area. And the area versus height plot will help you to understand or identify the singlets and separate them out from the doublets. Now, along with this bending of the light, there is also going to be some reflection of the light along a 90-degree angle, and this is something which constitutes the side scatter. Now, side scatter and the forward scatter, these are two essential properties which are present within the cell. You don't need to label the cell with some special reagent or something to understand them, and they will be produced as soon as this laser light falls on this cell. Now, forward scatter is primarily determined by the size of the cell. So the cells which are larger in size, something like neutrophils and the monocytes, which we know are larger than the lymphocyte, will be having higher forward scatter as compared to the smaller cell. And side scatter is primarily determined by the cytoplasmic component of these cells, and most importantly granules. So you know that neutrophils, they have got primary granules, secondary granules, the tertiary granules. They will be having higher side scatter as compared to the monocytes. Although monocytes do have some lilac color granules in their cytoplasm, but those granules are very less. So their side scatter remains below the neutrophil, but will be higher than the lymphocytes, which are almost totally agranular. Then in addition to the granularity, minor increase in the side scatter is also produced by the cytoplasmic vacuole by the phenomena of total internal reflection. And something which I forgot to mention in my last class, a bit of effect on side scatter is also produced by the size of the cell. Now you see the DLBCL cell, they are very large in size, and they will be having a bit of higher side scatter as compared to the mature lymphocytes. Although you see both of them are agranular, still DLBCL will be having a bit of higher side scatter as compared to the normal mature lymphocytes. And this is how the forward scatter and the side scatter plot looks like in a real life when you're going to analyze your flow cytometry sample or the flow cytometry experiment on an analysis software. Then along with this side scatter and the forward scatter laser, this cell is also going to get bombarded with some more lasers which will help us understand the antigens which are present on those cells. And how do we understand about those antigens, or how do we target those antigens, are that we create an antibody and a fluorochrome fusion, and that antibody will go and bind to the cell. Now that fluorochrome will be excited by some more laser. For an example, the flow cytometer which I am using is BD Fax Lyric flow cytometer. That's a 3 laser 12 color flow cytometer. It has got 3 lasers as the name indicates. One is a green laser, second is a red laser, and third is a violet laser. Now let's see, when along with this scatter laser, this green laser strikes this cell, it is going to go and excite these 4 different green laser excitable fluorochrome, and they are FITC, PE, PE size 7 and PERCP. You can see that a single laser is able to excite more than one fluorochrome. However, the light emitted from these fluorochromes when their atoms fall down to their basal state is going to be different for each of these 4 fluorochrome, and that is how your machine will be able to identify whether a signal is coming from a FITC fluorochrome or it's coming from a PE fluorochrome, and so on. And accordingly, it will tell you whether this fluorochrome or the corresponding antibody to which it was bound is present on that cell or not. Now, along with this green laser, the cell also get bombarded with this red laser, which is going to go and excite these three red laser excitable fluorochrome, and simultaneously a violet laser also hits the cell and excite five brilliant violet excitable fluorochromes. Now we shall start with the contents or what we have in our today's video. Now to make you understand that thing, what I have done is I have taken up this tube, and to this tube I have added some normal peripheral blood. So the normal peripheral blood will contain red cell, they will contain the platelet, then there will be the leukocytes, which are your neutrophils, monocytes, and various type of lymphocytes, which are B cells, T cells, NK cells, and some rare kind of cells as well. Now, along with this blood, what also I have added are some antibodies bound to some fluorochromes. We will not, go through those fluorochromes right now. That thing we will go when we are going to analyze that thing on the computer screen. Now, first antibody that I have added is anti-CD19 that will go and bind to the B cells. We know 19 is a pan B cell marker. It is present on all B cells, whether they are mature or immature. So the hematogens also contain CD19 on their surface. So this anti-CD19 and along with this fluorochrome is going to go and label your B cells, the mature B cells which are present in the peripheral blood. Why not immature? Because usually the immature B cells do not come in the peripheral blood. This is in contrast with CD20. 19 in contrast with CD20. CD20 is an antigen which is present only on your mature B cell. It is lost at the stage of plasma cell differentiation, and it is not present in your precursor cells, which may be malignant or maybe the normal B cell precursor, which we also call as hematogon. Then I have added anti-CD56. This is going to go and bind to CD56 antigen, which is present on your NK cells. These NK cells in addition will show you CD7 positivity, but will be negative for CD3 as well as CD5. Then I have added anti-CD3. This CD3 antigen we know is present on almost all your normal mature T cells which are present on your peripheral blood. Immature T cells which are CD3 negative are not seen in peripheral blood, and if present, it indicates that you are dealing with some immaturity thing. And that is, what is that? That is the T cell precursor lineage leukemias, also known as T acute lymphoblastic leukemia. The normal CD3 negative T cells are not present in your peripheral blood. They are present in your thymus, where T cell maturation and differentiation is actually taking place. Then I have CD7 and CD5. They are another group of pan T cell markers which are present on almost all your normal peripheral blood T cells. Although CD7, I will say, may be negative on 5 to 10% of the normal peripheral blood T cells. But CD7 will also label your NK cells, as I have told you previously. Then I have added CD4, I have added CD8. These are the antigens which are present on your T cells, of course, but on a separate group. So a group will be CD4 positive, a group will be CD8 positive. The double negative means something which is negative for both CD4 as well as CD8. That population of T cells is very small in your peripheral blood. And if expanded, that is something that is a type of a malignancy or maybe a reactive process also. We are going to deal with it when we are going to see those kind of cases later on. Then you also get information about the size through the forward scatter. Then you also get information about the granularity by using the side scatter. Now, after addition of all these antibodies, what I'm going to do? I'm going to do processing of this sample for surface staining. What are various type of staining that you use in flow cytometry? What are the protocols, surface staining, cytoplasmic staining? How do you do them? Those things I'm going to tell you one by one, starting maybe from the next lecture or maybe after that, or I'll just keep on dropping one by one that what are the various type of sample processing that you use. So for now, I'm going to stain the surface cells, the cells on their surface with the help of these antibodies. And during the processing, all these red cells and platelets will be removed and may be seen as a debris. And after that, I'm going to run that sample on this BD fax lyric flow cytometer. The file which is generated in turn from this flow cytometer is in FCS format. This is something like image file, which may be JPG or PNG or TIFF file. Similarly, the files which are generated from the flow cytometer is usually FCS when you're talking about the BD sets of instrument. The Beckman instrument, they produce something which is called as LMD file. Although there is no difference between the two, there are two different company things which are produced. Now this FCS file I'm going to analyze on this Kaluza 2.1 software to demonstrate you what are the different types of gates and what are different type of plots that you use in flow cytometry. Now, just a quick word about this Kaluza. Now, the Kaluza is a very handy software for the labs who are analyzing a lot of flow cytometry samples every day, and also for those labs who actually use a lot of brilliant violet fluorochromes. Why? Because brilliant violet fluorochromes tend to give a problem which is something called as compensation issue. What compensation is and how it affects your experiment, those things I'll not be telling you right now. Those are quite difficult thing, or maybe I can say complex thing. I'll be able to take a complete lecture on them and how you can overcome that issue. That is something which I will tell you, something which is called as the offline compensation, or you can also use the pre-acquisition compensation as well. So those are the things which we will not worry for right now. We will have a separate class on that thing later on. Now let's just go on to the computer screen and analyze how the file which is produced from these antibodies bound to your normal peripheral blood will help you to understand various type of plots and various type of gates. So now let's just go on to the computer screen. So everyone, this is how a Kaluza 2.1 analysis screen looks like when there is no experiment actually being opened up. And so you can see that this analysis list is empty and you do not see any kind of options displayed here. The options will be displayed as soon as we are going to open up an experiment. So right now I'm just going to go and open up the experiment that we have actually acquired, as I've told you earlier. So I just go to this open file, and from the desktop I'm going to open up this normal tube which I've acquired for specifically for this class itself. So the experiment is getting opened up. My computer is a bit slow because it's not meant to be used with Kaluza 2.1. For the time being, I'll close down these windows. So now you can see, as soon as this experiment is open, this is the normal tube. This is the tube which I have acquired with those antibodies which I told you previously. So as soon as you open up this normal tube or this normal tube experiment, you start seeing a lot of options here on the upper side as well as on the left hand side. So right now what I'll do is that I'll just clear this analysis list so that we have a full screen view. So in all, you have got three tabs at the top side. One is plots and table, second is gates and tool, and third is the edit tab. Along with that, you have got 4 tabs on the left hand side. Let's just go through them quickly one by one. First, in the parameter tab, it shows you what are the various properties that you have acquired. So you have acquired forward scatter area, you have acquired forward scatter height. Then these fluorochrome fit C, PE, PE size 7. Corresponding to these fluorochrome, you can see that there is an antibody name which is been written here. So likewise here, PE size 7 is conjugated with CD5. So you can see PE size 7, along with that CD5 is written. Similarly with APC, CD4 is written. So these are the fluorochrome, and that is the corresponding antibody to which this fluorochrome has been conjugated. It is actually we tell to the machine that in APC it's there, the CD4 is there, and similarly in PE CD7 is there. So it's you who tell to the machine that this is the fluorochrome and this is the antibody attached to it. So you can see we have CD8, CD7, CD5, CD4, CD45, CD38, CD3, CD56 and CD19. Now let's go to the second tab and I'll just close this parameter window for the time being. Then I have got this compensation tab. So this compensation tab actually shows you the compensation matrix. What compensation is, that thing we are going to deal later on, and how this matrix is generated, that also we are going to deal later on in one of the next or maybe one of the coming up videos. Then you have got color. I will just close this compensation plot as well. Then you have got color precedence. I'll show you what color precedence is. It's basically to bring up a gate forward above the other gates. How that thing is used, I'll just show you the time when I'll do the analysis. Then you have got protocol option, and this protocol option is actually for enumeration of absolute count, usually used when you are doing CD4 counts or doing CD34 stem cell enumeration. That is the time this calibration or protocol option is used. We shall not be using it right now. Now let's come on to these three tabs at the top, starting with edit tab. I'll not show it to you. It's just a selection thing which is coming here, and usually this thing is not used. Then on the plots and table, it gives you option of various kind of plots that you have, and in the gates and the tools, it gives you option of various type of plots like various type of gates like linear gates and divider gates. Then you have got quadrant gate, hinge gate, polygonal gate, rectangle gate, and the ellipse gate. They are all together the same. It's only about what kind of shape the gate takes. Like in polygonal, it is a freehand gate. Rectangle comes in a form of rectangle as the name indicate. Ellipse gate will be in form of a ellipse. Auto gate is when you just choose this gate and click onto a population, it will automatically make a gate around that concentrated group of cells. Now these options of select, annotation, shapes, overlay, these are basically to mention if you want to label your plots with something. However, routinely these things are not used, so we'll just skip through them. We will just focus ourselves on the plots and how do we apply gates on them. So basically I'll just show you two types of plots. One is the histogram plot, which is very important plot. So I'll just click on the histogram plot, and as soon as I click here, a histogram plot is being formed. I'll just expand this thing a bit. So you can see you have got a parameter on the x-axis, and on the y-axis there is count. This particular histogram plot is actually something like your red cell histogram plot or the platelet histogram plot which you see on your CBC counter. So for an example, I'll just show you. So on the choose parameter, what I'll do, I'll just pick up a parameter. So like here, I'll just pick up CD3. So when I have pick up CD3, you can see these are the events. These are the events or the cells that we have acquired. So you can see these cells have got divided into two components. One is this heap. This looks like a heap itself. So one is this heap. These are the cells which are actually bound, which have actually gone and bound to BV421 and giving signal through BV421. That means these are the cells which have bound to CD3. So what you can say that these are the T cells. Now this is the histogram plot. Routinely this plot is used for PNH testing when you want to show what are the various types of red cell or type 1, type 2, type 3 PNH red cells. That is the time it is used. As well as that, in addition to that, I routinely use it for my ploidy analysis when I'm doing ploidy analysis for the B cell acute lymphoblastic leukemia in pediatric cases. Then in addition to this histogram plot, the second important type of plot that you need to see is the dot plot, and most of our analysis takes place on a dot plot. So dot plot has got two axes again. One is x-axis and the second is y-axis. And now you can see that both of these axes have got an option of choosing a parameter, while it was only an option to choose a parameter on x-axis when we are talking about the histogram plot. The second y-axis was automatically being taken as count. Now let's see what happens when we pick up or when we choose one particular parameter on both of these axes. Now let's say I will just choose CD3 on one of the axis, and I'll choose CD19 on the other axis. Now you can see automatically you got a lot of dots here, and each dot represent a cell, or I shouldn't say a cell, I should say a particle. So it can be a red cell, it can be a platelet, or it can be any of your leukocyte. But red cell and leukocyte are usually not seen, or red cells and platelets are usually not seen. Why? Because they are removed, as I told you earlier, at the time of processing. So each of these dots actually represent one or the other type of leukocyte. So now let's see. So you have got CD3 and you have got CD19 on y-axis, CD3 is on x-axis. You can see broadly all these cells, all these events have formed three separate groups here. So you can see this group as well as this group. Both of these groups, I'll just gate them out. And what exactly gating is? Actually gating is nothing but selecting a particular group of population. So what I'll do, I have taken a polygonal gate and I'll just keep on clicking something like this, and there will be a freehand. I have used a polygonal gate, and there is a selection, or this is what we call as gate. I have actually selected only this group of cell. Then I'll take this polygonal gate again and I'll choose this group of cell as well. Then I'll take this gate once more and choose this particular set of cells. Actually, this particular set of cells is not alone, and it is comprising of two separate populations. As you can see, one is this and another one is this. But for the time being, I have just taken them as a single population. So how do we identify something as positive for a marker, or how do we identify something as a negative for marker? So now you can see this green particular set, this green particular group of cells has come very ahead on this x-axis. Actually, this is they have come ahead. Why? Because these are the group of cells who have gone and bound to CD3. So these are expected to be T cells. But if you see the expression of CD19 bound BV605 on these cells, you can see that these cells on the y-axis, they tend to remain towards the 0 point. So what we can say, that these cells are positive for CD3 but negative for CD19, and that is what is expected, because we don't expect the T cells to express CD19 antigen. Why? Because CD19 is an antigen which is associated with the B cells. Then you have got this red group of cells. This red group of cell has actually bound to CD19 BV605, and if you see on the x-axis, they remained near the 0, which means these cells have, this red group of cells have only gone and bound to the CD19 but not bound to CD3, and so they are the B cells, and as expected they have not bound to the normal CD3 which is expressed on the T cells. Then you have got this group of cell. This group of cell is actually negative for both CD3 as well as CD19, because for both BV605 or CD19 and for CD3, this group of cell had remained at the origin or the 0. So what you can say is that this group of cell is positive for CD3, the green cells, and they are the T cells. Red group of cells have gone and bound to CD19, these are the B cells, and these are rest of the cells. And what are the rest of the cells? Of course, you know, the rest of the cells are the neutrophils, the monocyte, as well as the NK cells. So this is how we identify the populations. Now let's see how systematically we can identify the component of our lymphocyte population, or how we can actually separate or dissect out our lymphocyte population into its respective components. So for the time being, I'm going to delete both of these two gates as well as both of these two plots. And my computer is a bit slow, so you have to bear down with me for that. It's just happening, guys. Just wait for a second. Yeah, it's gone, and so this is also gone. So let's start with plots and tables. I'll make a lot of dot plots. So see, I have made so many dot plots, and this is how that will help in multiplexing. I'll just choose them all and increase their size for you. So as I've told you previously, that we first see the forward scatter area and forward scatter height. And why do we use that? We use that to exclude out the singlets. So what I'm going to do, I'm going to take forward scatter height on one of the plot and forward scatter area on the other side, and what you will get a parabola. And these are the cells which we want to exclude. Why? Because we don't want to study these cells. So I'll just pick up a gate, I'll just pick a polygonal gate and pick up these group of cells which are lying on a parabolic curve, and rename these cells as singlets. So these are the singlets. And also I'll change this color. I'll keep it some dull color because usually singlets are not the population of interest. What population of interest is, that is something which we are going to discuss in the next class. So this is the singlets which I have chosen. Now you can see it's written ungated here. Ungated means all events are being shown, but I don't want to study them. So I'll exclude this group of population. And how I will exclude this group of population? By choosing only the singlets here, which means that now I'm going to study only the singlets. So when I'm going to apply any coordinate on X or Y axis here, it will only show me this group of events and will not show me these cells at all. And that is how you exclude something which you don't want to study. Now the second thing which we always do before we start analysis is that we exclude out the debris. In spite of whatever fine processing you are doing, some amount of debris will always be present, and you have to exclude that out. And how do we exclude it? By plotting a forward scatter area, a side scatter and a forward scatter plot. I'll keep side scatter on the y-axis and forward scatter on the x-axis, and this is how it appears like. So you see, you have got three different groups which have been formed. One of them are these groups. This group of cell has got a very high amount of side scatter. You can see on side scatter axis they are lying at way ahead level than these two groups. So what are these cells which are having a lot of side scatter? Of course, we know side scatter is a marker of the granularity. So we expect all types of granulocytes will come here. So this group will contain the neutrophil and the eosinophil. Then you have got these cells, this group of cells. I'll just try and get it for you. So then we come on to this group of cell. This group of cells are those cells which are having side scatter which is lesser than these neutrophils. So we know that these are not the granulocytes but have got side scatter which is lesser than the neutrophils. But in terms of forward scatter, this group of cells lies ahead of this group of cell. That means these are a bit of agranular cell having a larger size, and this is the place where you get the monocytes. And then the final, this group of cells is the cells which is both small in size as well as do not have any granule. So can you identify what are this group of cell? These are the lymphocytes. These are the small agranular cell. Then you have got these group of cells. You see. So these group of cells, they are actually the cells which are very small and may have variable amount of side scatter. So can you recall some cells which are even smaller than the mature lymphocyte? Of course, I understand you're talking about the debris because we have already removed the platelets and the red cells. So the only thing that remains of a size below lymphocyte is the debris. So these are the debris cells, the blue cells that I have labeled. We always exclude this population out as a second step. So now what I'll do, I'll just for the time being delete these gates and just choose the non-debris events. And what are the non-debris events? The neutrophils, the monocytes and the lymphocytes. So I'm going to just choose these group of cell. And this is how I choose them. So these group of cells are the non-debris events. So I'll just label them as not debris, live cells or not debris cells. So these are the live cells. I'll just give them a dull color because this is not the primary site where we identify our population of interest. So this is the live cells. Now we are going to study only the live cells because we don't want debris to interfere in analysis. So I'll just choose live cells here. Sorry. And one thing which you need to remember for the rest of your life when you start analyzing flow cytometry is that this third gate, this third plot is the most important plot in the flow cytometry. This is what we call as a peripheral smear. And why peripheral smear? Because every particular group of cells comes and lie at a separate position on this plot. So this is what is called as side scatter versus 45 plot, and in most of the conditions this is the plot where you identify your population of interest. So now you can again see there are three clusters being formed. One is this cluster, which is actually having a lot of side scatter. And what are those cells which are having a lot of side scatter? These are the neutrophils. And you will see beauty of this flow cytometer, that as soon as I gate this group of cells, the same color will also be imparted to these cells wherever they are on any of our plot. So see, I have given red color to this population over here, but even this population over here is getting labeled with the red color. Alright, so these are the neutrophils here, and these same things are the neutrophils here. I'll just label them as neutrophils. Alright, so these are the neutrophils. Then you see some of these cells which are going actually above the neutrophils somewhere here. These are actually the eosinophils, but routinely eosinophils are not that high in number, so you don't get to see so much of eosinophils in every case. Then one more thing which I want to tell you is that basophils are something which during the time of processing lose all their granules. So instead of lying in this high side scatter region, they tend to come and lie just on the left hand side of this group of cell. So they will come somewhere here, somewhere here. Alright, so the next group of cells that I want you to understand is these group of cells, and these group of cells are having a side scatter which is higher than that of this third group of cell. So can you identify what these cells are? Of course, I have told you this group of cells are monocytes on side scatter versus forward scatter. So this is what is called as the monocyte region. And the final one left out are the brightest CD45. So this group of cells is having brightest CD45 and has got least amount of side scatter, and this is the lymphocyte region. So just remember this thing as peripheral smear. Always, like, you have to remember that the neutrophils have got a lobulated nucleus, the monocyte have got a very fine chromatin and they are larger in size. Similarly, you always remember this thing, that on side scatter versus 45 region, you get this group as neutrophil, eosinophil somewhere lying above it, then the group which is lying between the lymphocyte which are the brightest CD45 positive cells, they will be having very low side scatter, and lying between the neutrophil and the lymphocyte group will be the monocyte. So now what was our target? Our target is to how we can identify the subgroups of the lymphocyte, because we have only used the marker for identification of lymphocyte population. So now in all of our plots, we are going to study only the lymphocytes which are blue in color. Alright, so now you can see on rest of all these dot plots, you have got only the B or the lymphocyte group. I can just rename this group as lymphocyte so it becomes easy for you to understand. So I'll just rename them as lymphos. So this contains all the lymphos, the B cell, the T cells as well as the NK cells. And the favorite plot to identify or separate them into their subcomponent for me is my CD7 versus CD3. These are all surface marker. So you see, as soon as I'm going to click CD3 here, you will get actually three different groups being formed out of this single lymphocyte region. Okay, you can see all these cells are blue, which means they are all coming from this lymphocyte region. So now what I'll do, I'll just group out each and every one of these cell groups, and one of them is this, which is CD7 positive but is negative for CD3. You can see for CD3 it remains near the 0. Then you have got I'll just choose a square gate right now. Then you have got these cells which are negative for both CD7, which is on y-axis, and negative for CD3 as well, which is on your x-axis. And these are the cells. I'll just choose an ellipse gate to show you how the ellipse gate looks like. So this is all about the shape. So this is the ellipse gate. So can you now tell me what are these three group of cells separately? Of course, this is very easy. These are the cells which are positive for CD7 as well as they are positive for CD3. only a small number, you can see this small group of cells which is positive for CD3, which is now I have labeled as in magenta color. This group of cell E is actually negative for CD7 but only positive for CD3. However, these are the normal T cells. As I've told you earlier, up to 5 to 10% of the normal T cells may also be negative for CD7. But right now, these all are CD3 positive cells, the D group as well as E group which is contained within the D. So all these cells are actually your normal T cells. Then you have got this cell group which is positive for CD7 labeled as B, which is positive for CD7 but is keeping negative for CD3. These are the NK cells, as I've told you earlier. This group will be negative for CD5 but will be showing you positivity for CD56. Then you have got only this group of cell left, and of course I know what you are saying. These are the B cells which are negative for both CD7 as well as CD3. Now let's see all of them on different plots. So what I'll show you a CD19 versus CD56 plot. So what do we expect? On all these yellow color cells we'll be having CD19, and expectedly you have got CD19 on all these cells. That confirms that these are the B cells. Then you have got this B. So now these E and B are of same color, so I'll just choose a different color for them so that it becomes easy for you to understand. So I'll just give this B group a different color. I'll just give it a dark green look. So but still it is not being shown here properly. What should I do? I'll just highlight this group. So as soon as I'm going to highlight this group, it will get highlighted everywhere. So now you can see this B group of cells which were positive for CD7 is brightly positive for CD56. So now it is confirmed that all these cells are your NK cells, which we could have easily deduced from this 7 versus 3 window itself. And this D group of cells will be negative for both CD19 as well as CD56, because normal T cells don't express CD19 as well as normal T cells don't express any amount of CD56 routinely. So you can see how beautifully and how easily we can identify the component, or we can subdivide these lymphocyte population into its various subcomponents using 7, 3, 56 and 19 marker. And I have just used 5 markers here to show you this beauty. It's just 45, 7, 3, 56 and 19 that I have shown you. And if you're going to use a lot of markers, like I'm using 12 markers right now, you can separate out your blast population, you can separate out your monocyte population, you can study dysplasia on them, and similarly you can do a lot of beautiful things which we are going to study later on one by one. I'll just show you CD4 versus CD8 plot also and try to show you how does a T cell population. What are the T cells? These are the D group of cell. So after using CD4 and CD8 on 2 different axes, I'll just give or choose the D population. So you can see as soon as I've clicked it, 4 and 8, these normal D group of cell or the T cells have got divided into a beautiful CD4 positive normal T cells, a beautiful group of CD8 positive normal T cells, along with a very small group of both CD4 and CD8 negative T cells. These are both the double negative T cells and some of the gamma delta T cells which are also negative for both CD4 as well as CD8. A very small amount of dual CD4 and 8 population will be there. You need not to worry about those population. So this is all about how you are going to differentiate, or you are going to divide your lymphocyte population or any other population later on when we are going to study the cases. So guys, this is for now, and later on we will come back and we will identify we will study how do we identify the population of interest in abnormal sample. These were the normal sample. For the time being, just remember and try to appreciate one thing. You see, there is nothing which has been shown here in this region. This is what we call as dim CD45 region, and this is the place where you most of the times get your acute leukemia. Lymphoma cells will try to form a cluster in the mature lymphocyte region. However, some lymphomas which are larger in size, and as I've told you, because of the larger size, they may show a bit of higher side scatter. They may go just above the lymphocyte population. And that is how we identify a population of interest and compare them with your normal population to identify what is the positive, what is their expression pattern, whether they are positive for a particular marker or negative for a particular marker. Those things we will start studying the time when we are going to study the cases in detail. But for the time being, this is all about for the today's gating and separation technique. So guys, this was all about gates and plots. And in the next lecture, we shall be able to identify our population of interest. And this is one of the very important topic. In this, you are going to identify that which population of the various clusters that you get on flow cytometry plots you want to gate and study. And only on the basis of the expression pattern of various markers on that population of interest, you are able to get on to the diagnosis that you want to make. Now we shall be getting on to some serious stuff where we shall be applying or we shall be using our knowledge which we have gained from this basic lecture to identify what kind of malignancy that you're dealing with. And it's very important to know the morphology. The importance of that I'll show you when I'm going to take the next lecture where we shall be studying about the identification of population of interest. Till then, please subscribe to the channel and hope we'll be soon back now. Thank you.